Hello all, welcome to my channel. I'm back with another video related to data engineering. In this video, we will be talking something about Snowflake tables. So let's get started. Snowflake is a modern software as a service for data warehouses, and it provides multiple options when we are trying to create a table in there. And these tables serve different purposes, and each of them has their pros and cons. So let's see how those tables serve a particular business or a use case, and what are the options that we have. So in general, we have different types of workloads that we have or we want to run it in a Snowflake platform. Uh, one simple use case is because Snowflake is a data warehouse kind of a product. It helps us in analyzing large amount of data. So the most common table which is out there is called a standard table, which is nothing but an optimized table which has cluster index, which has micro partitions and everything. That that allows us to do analytics on top of columns, on top of table data that we have. And apart from these standard tables, we have several different tables that we can use, and we can leverage it in Snowflake environment. So if we have to look at the options that we have, is we have permanent table, we have permanent table or standard table are same. Then we have transient tables. Transient table is something which is a temporary table that is created by one particular process and is accessible to other processes as well. So the transient table lives across sessions that are there. Then we have temporary table, which is only scoped to a session. So for example, let's say you are doing some large scale processing. So we have some intermediate data that needs to be stored for some time, that can be reused multiple times. So instead of calculating every time, we can create a temporary table and store it. One good example of doing that can be, for example, let's say you are doing a geospatial analysis and you have, let's say, an area and you want to get an S3 index out of that. You can create it, store it as a temporary table while the processing is going on, and then you can leverage that whenever you need. It's only thing is that it is only available till the session is there. Then you have dynamic tables. Dynamic table is something which helps us with uh, automatically refreshing the data that is built on some other tables. For example, we are creating a pipeline where, let's say, we have two tables which are kind of a bronze layer, and then we have a table which is in the silver layer. If we want that whenever data gets updated in the bronze layer or ingestion layer, and the data in the uh, silver layer, or let's say from silver to gold layer, it needs to be refreshed automatically. We can have dynamic table in there, and it automatically refreshes it. Then we have event tables. Event table is something which is there for us to leverage what you call hotel or telemetry data that we want to collect. We can have that in the events table. So for example, let's say we have a process and we want to see the progress of that procedure that is going on from, let's say, it's a long running process. We want to log every event that is, let's say, that marks a particular stage being complete, or let's say some extra information that we want to emit so that it can be acted upon by external systems. So that's where these event tables come into play. We can log everything in the stored procedure, and those logs get written to the event table and can be processed later on, or can even be run analytics on top of it. Then we have hybrid table. So before we go to the hybrid table, let's say go from here. So we have external tables. External table is nothing but a table which is so when we have a standard table, when we load the data, the life cycle of data is tied to the table itself. But in case of external table, the life cycle of the data is external. In a sense, it can be managed outside of Snowflake as well. For example, let's say we have a table, we have data in Snowflake, sorry, S3 storage, and we create a table which we say that we have an external table. We can access the data as a tabular format, but the life cycle of the data is not managed by Snowflake itself. It is managed by someone else. Then we have directory table. Directory table is something similar to uh, a table that so if you have worked with DuckDB, DuckDB they can directly access a Parquet file, run analytics on top of that. This directory table is something similar where we can create a table on a data source which is listed or which is stored as a file. For example, if we have stage in Snowflake, so if we can create a table on the stage and that directory becomes a table for us. So this is auto-generated, provided a list of files in a Snowflake stage, so we can query or join the data. So for example, we can have examples that if some data is being dumped by some other company, let's say you have integration with third-party companies which are emitting some data which is not that frequently changed and it is kept in S3, so we can leverage. Oh, sorry, it changes or maybe frequently or not frequently, doesn't matter. They just simply dump the data and we have a table on top of it, and then we run analytics using that table. Then we have an iceberg table, which is nothing but a new table option, which is there in Snowflake. So we can manage this iceberg table with the catalog and the metadata options which are there on top of table format. So this allows us to, for example, we might have a lake house situation where we have multiple engines using the same platform or for the same underlying data. In that case, we can simply create an external table with iceberg and then access those data in Snowflake as well. And whenever that data changes, if we have catalog, which is, let's say if we are using the Polaris catalog, that gets refreshed and we get to see the data which is there. Then we have hybrid tables. So all these tables that we are talking is all tailored towards analytics. They are not tailored towards doing some real-time data serving. That's where hybrid tables comes into picture. This is a combination of real-time data with the tech or with the infrastructure backing of a warehouse table. So that's why it is called a hybrid table. It has the features. It has all the features, like it has warehouse, it has everything else, but it's instead of being a row or a column oriented data, it's a row oriented data. It allows faster updates, faster lookups and everything. So that's where this hybrid table comes into picture. Although I have mentioned materialized view is not a table, but since we are saying materialized view has a physical manifestation of a view that gets created. So that is also something good to know, that okay, there is an option that if we create a materialized view, it will create a copy of data, and that copy of data can be queried and run analytics on top of that. So these are some options. There is one more interesting new table type that has been created by Snowflake team, and that data is that table is kind of an interactive table. So this is a table type which allows us to serve data APIs. So basically, what will happen is the hybrid table. This is taking the hybrid table to a next iteration where it becomes a single point for data serving as well as for APIs or dashboards, or let's say BI tools that we have that can be leveraged using that can be powered using this particular table. The only constraint with this table is that this is a read-only kind of a table. There is no updates allowed. So there is no update. Only thing that we can do is either we can read from it, or once we have created, we can do an insert overwrite. So that every time we delete the older data and write the new data. So that way this table can work. The latency numbers for this table is in sub-second. So if for lookups, and so for example, let's say we have the same example. We have bronze layer, silver layer, and gold layer. So this will sit in the gold layer where the APIs are being served. So that is another interesting table type that we have. And if we see how we can access these things or how we can query these things, so we have sort table options. So we can sort tables in a particular database and schema. We can sort tables like to find out. We can even get the DDL of a table which is there, and then we can query the table names. We can say, so these are the different types. So event table, dynamic table, event tables. Then we have external table, we have stages, hybrid tables, iceberg tables, materialized views. We can just simply call so and list all the tables which are there. There are few things like fail-safe mechanism and other stuff that gets considered into. For example, permanent tables data remains until we drop the table. We can do time travel up to 90 days. Fail-safe is for 7 days. Fail-safe means if we deleted something, we can recover it back till 7 days, and it is for long-term storage. Temporary tables are until the session is active. There is no time travel, there is no fail-safe. The data is lost as soon as the session gets completed. Transient data is again something which is until we drop it, but the time travel is only for 0 to 1 days. There is no fail-safe, and intermediate and stage data can be stored in this external table. Well, it is externally managed, so there is no time travel, but there is no fail-safe. Yeah, we don't need to fail-safe because it's externally managed. The data remains in the data lakes. Dynamic table is generated on the fly, so there is no time table, no fail-safe there as well. Event tables have a configurable time table of 0 to 90 days, and fail-safe also can be configured, so that we have to do a cost benefit analysis and then figure out what we have to do or what configuration we want for the time travel or fail-safe. Hybrid tables can be local and can be external as well. It has a partial support for time travel, and there is no fail-safe, and the use case is for flexible data management, or let's say doing frequent updates. That can be something which is can be served with hybrid tables. Iceberg, which is externally managed table, is again time table is there. Time table is also supported by Iceberg tables by default. Failsafe is not there because the data is managed externally, and use cases is there for large scale analytics. One thing which is not there in the interactive ones, interactive table, again that has persistence is until we drop it. Time table is not there in there, and failsafe is I think it is 7 days for hybrid tables, interactive tables as well. And so this is where the different tables that we have, different options we can use, so uh, to leverage this types of tables we have, and uh, based upon the use cases we have, based upon the uh, particular uh, problem that we are solving, we can select a certain type of table. And to decide that, for example, there is an confusion, not a confusion, but many a times we will face this scenario that where we want to uh, find out whether we want to have, let's say, which kind of table. So that is, this is one flow chart that is can be useful. So let's say whether it will be using external table or external table with, let's say, iceberg. Uh, or Snowflake standard table, which one to use. So here is an flow chart, like is the data stored public cloud? If yes, then is the data needs to be stored in open formats, let's say, because you have, let's say, multi-engine, let's say, for example, the same data is read by Spark and same data is read by some other analytics tool as well, let's say Presto or something. Then if that is the case, then we can go ahead with Iceberg tables, which has full DAWL, DML and best performance is there. If not, if that is not the case, only Snowflake is going to read, then it is better to use standard Snowflake tables and load the data from the S3 location directly. Then, if that is not the case, if the data is not stored on public cloud, it is, let's say, in a file format, or it is coming from somewhere else, like it is being fed into Snowflake itself. So if we need the full DML, we can go ahead with external table with S3 compaction. But if we don't need the full DML on the data, we can go ahead with external table with, let's say, Apache Delta or some other scenarios as well. So this is one particular flow uh, that we can use to decide which tables types to choose. There is a bigger flow as well. This flow is for identifying like how to choose a table type or a materialized view in this flow. So for example, we start with the question is the data critical and requires long-term storage with the robust recovery? If we have these use cases, if yes, then we will have to go with permanent table, which has critical, which serves as critical data. It has time travel, it has fail safe. We can go back to 90 days. So that's the solution. Is the data temporary and only needed for current session? Then whether we go for a temporary table. If not, is the data non-critical but needs to persist with minimal recovery that we are looking at. So we can go ahead with transient table because it will not have, we don't want to recover it, but we want it to persist so that it can be used across sessions. So we can go ahead with transient table. Then if those conditions are not met, is the data stored externally and cloud storage required? Let's say, for example, S3 or somewhere else, then we can go ahead with external table. If it is stored in external table also, if not, either it can be external table or iceberg tables, this is fine. If the goal is to automate declarative data transformation pipeline, then we can go ahead with dynamic tables. If not, then is the data stored in iceberg format? If yes, then we can go ahead with iceberg table. If the goal is to query files in a stage, then we can create a directory table and just query it. If not, is the goal to capture, monitor logs or events, then we have, if that is the case, then we go for event table. If does the workload require hybrid or transactional table capabilities? If yes, then we go with hybrid tables. If not, is the tables powering? I am just adding one more flag in here, that if we are targeting for BI use case, then we can go ahead with interactive tables, which is there in general preview as of now. Public preview. Then if is the goal to optimize query performance on single table with aggregates? If yes, then we go ahead with materialized view. Otherwise, we reassess the requirements and default to permanent or transient table. So this is one nice flow chart that we can use to find out which tables we should be using. So this was it for this video. Hope this was useful. And if yes, do share this video, support the channel, and keep rocking. Thanks.